This video shows you how to set up your device to measure heart rate for HRV biofeedback via ECG. ECG is the first of two different means of measuring heart rate, and the MindBody Training Tools software can work with both. ECG is basically a measure of the electrical voltage produced by the heart. The second way of measuring heart rate is with a device called a pulse oximeter, which uses a method called photoplethysmography, or PPG. It's a bit less accurate than ECG, but more convenient to set up. There's another video for PPG setup. The MindBody Training Tools HRV application also requires a measure of breath. That's also covered in a separate video. A USB dongle looking something like this serves as a software license key. It looks like a memory stick, and indeed that's what it is. It holds the software that you'll need to install, but beside that you need to connect it every time you run the software. It's worth quite a bit, so please don't forget to send it back at the end of your rental, along with the device and its associated parts and packaging. I cover software installation and setup in another video. This is the GP8 amplifier. We've used it earlier in the course for EMG biofeedback. Besides EMG, the GP8 can measure ECG. The physical setup for measuring ECG is much the same as for EMG. The main difference between detecting heart rate and muscle tension is in what the software does with the signal. Again, the GP8 connects to the computer via its USB cable here, and you don't need to do any software driver installation for this device. To measure ECG, we need the same three sensor cables as for EMG. The black and the white are the active sensors. When they're connected to the skin, they can detect the heart from pretty much anywhere in the body as long as they're on opposite sides of the heart. So, just as with EMG, we'll put them on the wrists, around about where you'd feel for a pulse. One small difference to the EMG setup is that it does make a difference which way round you put the two actives. To start with, I suggest you put the white one on the left wrist and the black one on the right. We'll come back to this point later. The green cable is the ground. It's also positioned on one or other of the wrists. It doesn't matter which one. The three cables plug into the front of the GP8 device like this. On my rental devices, I've labelled the sockets W, G and B for white, green and black. Again, as with EMG, you can use self-adhesive pre-gelled snaps that fit into the head of the cable and then stick onto the skin, or you can use the dry, reusable snaps, held in contact with the skin using wristbands. Both types have studs that snap into the head of the cable. Now, to measure heart rate, we only need to be able to detect the prominent spike in the ECG signal that comes once per beat. It doesn't matter if the signal is quite noisy because we can see the spike just the same. What this means is there's little to be gained by having a better quality connection. Using pre-gelled sensors and cleaning the skin doesn't really make the heart rate measure significantly more accurate. I personally find it simpler to use the dry reusable snaps. There's no need to detach the snaps from the cables between sessions. Just a word about care of the cables, because it is possible to damage them. Never pull on the wire part of the cable when you're disconnecting them from either the skin or the amplifier. Instead, always take hold of the plastic casing or housing part. Never bend the cable too sharply, for example when you're coiling them up, because kinks will adversely affect the signal. Don't wrap them around the amplifier box. Now you're ready to start the software. Again, there's a separate video showing you how to run the software, but I just want to say here that you can check the ECG signal in the software. Although you need a breath sensor to work with the HRV application, you can just check the ECG signal without it. It's going to look something like this. The main thing is you can see the prominent spike that crosses the dotted line here. That's the basis of heartbeat detection in the software. In rare cases, the signal looks so noisy or fuzzy that the spike is rather swamped. If that's the case, you might need to take steps to get a cleaner signal, for example by using pre-gelled snaps or by cleaning the skin with rubbing alcohol. But first, make sure that your arms and shoulders are relaxed, because muscle tension can swamp the heart signal. Sometimes the ECG trace looks like it's upside down, with the spike more prominent in the lower part of the chart. If that's the case, you can swap over the two actives between left and right. Remember which way around works best for you for your next session. Let's talk about what might go wrong. First, just to repeat the point about muscle tension, if your arms, shoulders or hands are tense, the signal from the muscles will swamp the heart signal, so you need to sit fairly still and relaxed. Now, having said that, the software can tolerate small movements and it can recover when it does lose the signal, so don't worry too much about, for instance, adjusting your posture. Next, remember the GP8 runs on batteries size AAA. If you've rented, I've included rechargeable batteries plus a charger. I find these work well enough and usually last for several weeks before needing a recharge. If the batteries are completely flat, you won't see any trace at all in the software. If they're partially flat, the signal can misbehave. In the software, there's a simple battery checking application. 2 AAA batteries nominally give 3 volts. It's less for rechargeable batteries. In my experience, about 2.5 or upwards seems to be fine. Again, don't worry about the impedance reading that's also given with the software application. The battery compartment is at the bottom of the GP8. The cover slides off like this. If you need to replace batteries, please be careful to insert them the right way or you risk damaging the device. In the EMG setup video, I talked about electrical interference. This can also be a problem for ECG measurement, but in general the software should be much more tolerant of interference. Again, you only need to be able to see the prominent spike in the ECG trace. If there's really heavy interference, it could swamp that signal. If that's the case, you can try a few things. Remember, interference comes from other electrical equipment, including the mains. Try to shield the device, and especially the sensor cables, from other electrical sources. Especially watch out for laptop transformers. Run your laptop on the battery if need be, and disconnect the cable from the mains.